So we're doing these hangouts for World Space Week. Uh, World Space Week was actually on October 4th to 10th, and we're celebrating World Space Week this whole month. And CB Devgan sir, who's with us on the stream, is the national coordinator of World Space Week. So for that, we're trying to do a series of talks called Space and Astronomy Talks, and getting some some of our astronomer friends to share their views of the universe with us and our students and the public. So this is part of a series of space and astronomy talks, and we are going to we've been doing this all week, getting some astronomers to talk to people so that we all find out about different things about what's going on in the universe. So I think we'll go ahead and start now. We have with us today Professor Patrick Miller. Professor Miller is a professor of mathematics and astronomy at Hardins Simmons University in Texas, US. He started the International Astronomical Search Collaboration, which is IASC, as many of us know, and it's a program in which students worldwide look for asteroids and make original discoveries of main belt asteroids. He's a guest researcher in astronomy at the Lawrence Berkeley National Lab and a PhD advisor in astronomy at the University of Southern Queensland in Australia. So Patrick is associated with universities all over the world, it looks like. And oh, we at Space have been lucky enough to have worked with IASC for the last few years, participating in the asteroid search campaign. And we are very eager to hear what he has to say to us today. Patrick is going to speak about debris fields in the solar system. We also have with us here today Mr. C.B. Devgan, who's president of Space Foundation, and he's going to be interacting with me and Patrick Miller today, Professor Patrick Miller, as we do this hangout. CB, would you like to say a few words, and then we'll turn it over to Professor Miller.
Yeah, Professor Miller is a kind of a person whom I know for the past, I think, more than 6 years, and our interaction started with the asteroid search campaign. And I must say that his enthusiasm and the way he gets things going in astronomy, and especially for the asteroid search campaign, plus the the Internet Telescope project which he had started with us. So it would be a kind of a opportunity for us to hear something apart from the asteroid search campaign and the Internet Telescope thing. What are his views on the debris in the space? So I'm very eager to just uh, give the mic to him so that he can start sharing his thoughts with us. So without any further delay, I think we should hear what he has to say, and then later on we can ask him questions.
Yeah. So welcome, Professor Miller. Please tell us what about the debris in the solar system.
Okay. Thank you, Mala and Dr. Devgan. Isaac has been very pleased to work with your organization over the past several years, and we hope to work with your organization for many more years to come. Let me share with you a short presentation I have on the solar system debris fields. All right. Some of this debris actually poses a threat to Earth, and this is one of the reasons that we formed ISAC, or the International Astronomical Search Collaboration. The time is 7 o'clock in the morning on June 30th of 1908 in a town called Vonavara, Siberia. As a on the slide, as I say, a man was sitting on his front porch minding his own business, when suddenly he was hurled from the chair and experienced heat so intense that he felt as if his shirt was on fire. He was standing 70 kilometers away from an airburst of an asteroid. The asteroid was 40 meters in diameter. It weighed over 100,000 metric tons. And that airburst heated the Earth's atmosphere to over almost 45,000 degrees Fahrenheit. That's 4 to 5 times the temperature of the sun's surface. And it released the equivalent energy of a 4 megaton hydrogen bomb. Now, no one was killed in that explosion because it was in an isolated region of Siberia. Now, hundreds of local deer, elk were killed, and 2,000 square kilometers of forest was obliterated, and 80 million trees were laid flat and stripped of their bark. Here's the graphic showing you what we think happened. Asteroid 30 meters in diameter, weighing 100,000 metric tons. It airburst, and on the right here, you actually see photographs taken by an expedition in, I think, 1923. It was a number of years before they got up there to actually look. And there you see some of the trees that were laid flat. And on the bottom there, you see a large area of land that was just absolutely obliterated completely. Yeah. This shows you where it hit. The circle you see here is where this thing airburst, and it's called the Tunguska event. What's interesting, or could have been very tragic, had this thing not struck at 7 o'clock in the morning, but it struck 5 hours later, it would have landed, it would airburst over St. Petersburg. In 1908, St. Petersburg had over 1 million people living in it, and those people would have been seriously injured, and some would have been killed. The current date, it was 9 o'clock in the morning on February the 13th in 2013, just last year. On that morning, there was an airburst that took place over Chelyabinsk in Russia. That's also located near Siberia. That airburst produced from an asteroid, produced a shock wave that blew out windows, doors. It even collapsed the walls of nearby buildings. 1,200 people, no one died, but 1,200 people were injured by flying glass and other debris that was caused by the shock wave from that airburst. The explosive power of the airburst was equivalent to a small nuclear bomb, but it airburst about 60 kilometers in the air above the city. This is the first time in recorded history that a large population of people have been injured by an exploding asteroid. And had it been closer to the city, those 1,200 people could have possibly lost their lives. It could have been much, much worse. What I skipped over, there was an event that took place 65 million years ago off the coast of Mexico in the Yucatan Peninsula. Only this was an asteroid that was as big as Mount Everest. It was 10 kilometers big. When it impacted the Earth, it created a crater that was 360 kilometers across, and it dug into the Earth as deep as 35 kilometers. That event was equivalent to about 3 billion of the events that took place in Tunguska in 1908. And in that event, 50% of life on the Earth was destroyed, including, we think, the dinosaurs.
Yeah.
Now, those events took place a long time ago, but the threat still exists. Here's an asteroid about the size of 3 football fields called Apophis. And Apophis crosses Earth's orbit and has passed very close to Earth. Now, it's 300 meters across. Like I say, it's the length of about 3 American football fields. If we were to be hit by this would be about equal to 130 Tunguska events, or about 500 nuclear bombs going off all at once.
Oh.
Will it hit the Earth? Probably will. When it passes near us, very close to us in 2029, we don't think that it will. But it comes back around 7 years later, and during the close passage in 2029, if it passes through a certain region around the Earth, it will alter the orbit, and it will come back and actually hit the Earth. If it does hit the Earth, astronomers know where that will happen. You can see the dotted red line there. That's the region where Apophis, if its orbit's altered in 2029, will hit the Earth in 2036. There's about a 50% chance it will be in the Pacific Ocean, and if it does hit the Pacific Ocean, it will flood all of the coastal cities that were in the Pacific, including the western coast of the United States, Japan, Asia, New Zealand. It would be a catastrophe.
But that would depend on if it does pass through that area, the gravitational.
Yeah. And astronomers, they estimate it'll be about one out of about 80,000 chance of it doing that. So we don't think that's going to happen.
Okay.
But keep in mind that these passages continue years after years, and eventually the conditions will be right so that it will hit the Earth. But we don't think that's going to be in the next 20 or 30 years. Now, returning this event that took place in Russia last
2013 years.
Right. I thought I had some pictures of it. Let's see. Let's see. Here we go. Let me page through this. I was telling you about the one that airburst last year in Russia. Here's a factory wall that was knocked down by the shock wave. This was a public building, and you can see all the shattered glass on the floor. People were walking along that walkway at the time of the airburst and were cut by that glass. Here's the trail it left after it flew near the city. And here's when the airburst took place from somebody's webcam on their car.
I think the most of the event was recorded by the dash cams of the.
Oh yeah, there were lots of coverage.
Yeah.
So let me show you what it is that is causing all this damage, killing the dinosaurs, threatening the Earth in 2039, and blasted a 1,500 square kilometer field of in Alaska in 1908. These are typical objects that we're looking at here. These are called near-Earth objects, or near-Earth asteroids. Now these are much bigger than the one that destroyed the dinosaurs. This one that's marked Eros on one side is about 4 times the size of Mount Everest. If that were to hit us, that would probably kill all life on Earth. That would probably be the end of everything. But they're irregularly shaped pieces of rock. They go all the way down to the size of footballs, up to the size of mountains. And there are thousands of them, maybe millions, that are wandering in the inner solar system where we live and pose a threat. Now here's a graphic that shows you where most of this debris is found. If you look at the bottom here, you see that the green donut-shaped, torus-shaped region. That's where most of this debris is located. It's located between the orbits of Mars and Jupiter, but on occasion, the primary culprit is Jupiter. That debris gets dislodged from the main belt and sent inwards into the inner solar system where Earth resides. And those are your near-Earth objects, and those are the things that airburst over Tunguska, airburst over Chelyabinsk, and landed off the Gulf of Mexico 65 million years ago. That debris coming in from the belt. Well, I want to talk to you very briefly then about how Hardin Simmons University, or IASC, is going to save the world. ISAC was a program, as Dr. Devgan explained, that in which space participates. It's an online educational outreach program in astronomy. It's for high schools and colleges. And students from all around the world receive images from professional telescopes the day after that they're taken. And then they look through those images and actually make original discoveries of asteroids. And those discoveries then are reported to the Minor Planet Center at Harvard and also the JPL in Pasadena. We started in 2006. We had 5 participating schools, but now the program has more than 500 schools located in 80 countries. And during the intervening 8 years, students have discovered 920 main belt asteroids, 2 of which were Earth-threatening, like the one that, like Apophis, although the one that they discovered didn't hit the Earth, but will in the future, and a number of asteroids that are in and around Jupiter. Of those 920, 33 of the asteroids have been cataloged and numbered by the International Astronomical Union in Paris, and once they're numbered, and it takes about 6 to 10 years for that to happen, then those asteroids can be named by their student discoverers. And so 33 of the asteroids discovered over the past several years have been named by the students. This is how it flows. I'll go over this very quickly. We get the images from an observatory. We put them up online into folders that are the students' folders, and they download them and they use a program called Astrometrica to analyze them. And if there's a discovery, then we repeat the process because we have to observe the asteroid within about 10 days, have to observe it a second time. So we go through the process again and observe it that second time and then report all this information to the Minor Planet Center. Now, these are some of the places where we receive our data. In the upper left, that is near the Great Wall of China in China. It's an observatory called the Jinglong Observatory at the National Astronomical Observatories of China. And there's a photograph there showing you the telescope that we use sometimes for images. We also get images from the Mount Lemmon Sky Center at the University of Arizona using its 0.81 meter Schlumann telescope. Most of our images, however, come from the observatory on the left, which is the Pan-STARRS Observatory at the University of Hawaii. That's located on Haleakala in the Hawaiian Islands on the island of Maui. And next to that, these are roll-off sheds, observatories at the Astronomical Research Institute, and we use images from their 0.61 meter, 0.81 meter, and most recently their 1.3 meter telescopes.
So we get it from all these telescopes in IASC?
Well, yeah, ISAC gets all from all those telescopes, but we run different campaigns depending upon, we have campaigns for Pan-STARRS, we have stands for ARI, we have campaigns for the Schulman telescope.
Right.
Now, what makes the Pan-STARRS telescope interesting is it's not the world's largest telescope, although it's large at 1.8 meters. It has the world's largest digital camera. That camera takes one image that's very big, 3 degrees across the sky, and it contains almost 1.5 billion pixels. They're huge. During a campaign, when we run a Pan-STARRS campaign, we get one of those images, or one set of those images per week, and we partition them up into over 200 sub-images and distribute those out to schools. From one image, students will discover as many as 150 asteroids. Slow to change. It's not changing. Here we go. These are some other, our other collaborators, and this is where I'll draw this to an end so students can ask me a question. We have another set of telescopes around the world that do the follow-ups, because we have to observe these asteroids twice within about a 10-day time period. We have a facility in Markleeville, California that we use, telescopes that we get through Cardiff, Wales, that are located in Hawaii and also located in Australia. Telescopes here in Texas, and the one at the bottom is a telescope located at the Kitt Peak National Observatory here in the United States.
So you send it to all those observatories, or to any one of them for follow-up?
We send out a notice. We have a website that sends out notices on the discoveries, and then the observatories come to that website and gather the information they need to make the observations. And here are some special facilities that we use only if we have a slow-moving asteroid or a fast-moving asteroid. Fast-movings are the near-Earth objects. These are telescopes we use, including Astronomical Research Institute, or a larger telescope, the Magdalena Ridge Observatory, that's here in the United States and New Mexico, and an observatory in northern Italy called the Schiaparelli Observatory. They also do follow-ups for the students. And let me just tell you that, well, let me show you this slide. I always like to show this one. When it changes.
I think it's changed for us.
There we go.
With somebody putting up.
All right. These are some of the students who participate in the program over the years. This is a group in Poland that participated, and at the time we were giving out awards, and this is a student receiving one of his awards. When they have their celebration, the entire city comes out. The aunts, the uncles, the cousins, everybody comes out.
That's great.
Here we go. This is a group from India, part of the space All India Asteroid Search campaigns that we run each year. Oh, do this one. These are students in Mozambique. This is a group of students in the United States. Made some discoveries. So this group of students right here is from Japan, and they are in the process of looking for and discovering asteroids. This is Portugal, and this is China. There's Bulgaria, Brazil, and some other students. This girl is here in the United States, in Massachusetts, high school student, made a discovery and received some recognition from her local astronomy club for having done that. Finally, let me just say that I need to tell you that IASC is free. There's no cost to participating schools. The 500 schools that participate, it's free. IASC is run by 20 volunteers from all over the world, and I've not met most of these people. I communicate with them by email and Skype. And you see here some of the countries that provide the volunteers, and including these volunteers are centers like SPACE that go out and locally recruit teachers and schools to participate in the program.
Yeah.
So with that said, I'd be happy to answer some questions.
Yeah, thanks, Patrick, for that great talk. Since many of us have been participating, many of our students and people and our viewers know a little bit about IASC, and I think they're pretty excited about your talk. And we have several questions, I don't think
All
you
right.
and CB, Dave Gonzalez, can see the questions. So I'll
No, I
just
can.
read out some to you.
All right.
Okay, we have a question from Shambik Ghosh asking, thank you for the informational talk. I would like to ask you why asteroids burst in air. Is there something volatile in it? So
No,
basically, what is an asteroid burst?
it's caused by stress. When they enter the Earth's atmosphere, they're moving around as much as 70 meters per second. When you move at that speed to the Earth's atmosphere, the atmosphere creates forces, stress forces on the asteroid that actually break it apart. Most asteroids that enter the Earth's atmosphere shatter into hundreds and hundreds of pieces, and they spread out over the land. But it's aerodynamic forces that cause that to happen. It's not something explosive inside the asteroid. It's all kinetic energy.
Thanks, Patrick. We have another one from Geetika Mehta, uh, and the question is, what are Kuiper belt objects?
Oh, I'm glad you asked that question. That's another asteroid field that is out past Neptune. Sometimes we call them TNOs or trans-Neptunian objects. An example of that would be Pluto. Pluto is an example of a TNO or Kuiper belt object. We just sent a proposal in to the University of Hawaii at PanSTARRS, proposing that we establish a new program in ISAC that will discover Kuiper belt objects. In the past 3 PanSTARRS campaigns, we've discovered in the data, and we weren't looking for Kuiper belt objects, but we found them in the data. We had a high school in Taiwan make a Kuiper belt object discovery. A middle school in Portugal made one, and another school, I've forgotten where they're located, probably Germany, has made one just this past week. But that's another debris field, and we want to start programs in ISAC where we actually go look for those.
Thanks, Patrick. And we have another question by Abhinav Dubey, and I've also heard about the NEO and Comet search. Can you explain the objectives of that project?
What was the name of the search?
The NEO and Comet search.
Well, there are several surveys around the world that are looking for NEOs and comets are also considered to be NEOs because sometimes they pass near the Earth. But the Jet Propulsion Laboratory NASA has a program where they're looking for the ones that are dangerous, that pass close to the Earth and are big enough to destroy a city, for example. One of those size asteroids hits the Earth about every 50 to 100 years. One big enough to destroy a city. One big enough to destroy a state or a country. Those are probably every few thousand years. And the one big enough to kill all the life on the Earth is every 100 million years. So there is a program by NASA to go out and identify those big ones that pose a risk to Earth. ISAC participates in that search, along with all the other observatories that are involved with ISAC. Also are participating in that search, like PanSTARRS and ARI and University of Arizona. But that's what that program is.
Thanks. And here's a question from Neha Kaushik. Hello, Patrick, sir. I've heard about the Whipple shield that is used to protect International Space Station from space debris. Can you please elaborate about it?
You say it's a micrometeorite shield?
It's a Whipple shield that's on ISS to protect it from space debris.
Josh, I
Do you
don't know.
know about that?
I don't know what it
Okay,
is.
yeah, that's a different kind of debris we're talking about. Yeah.
I do know that the International Space Station would be subject to micrometeorite hits. These are objects about the size of your thumbnail or smaller, and so they probably have shields covering certainly the solar panels that would protect or vulnerable spots in the space station that would protect it from those hits. If it gets hit by a
Um,
baseball-sized object, that would be serious, very, very serious.
so are these, the debris you're talking about, that's also counted in space debris?
Yes.
That
The thing about space debris is that the smaller it is, the more there is of it. Each year or each day, tons of that debris falls into the Earth's atmosphere in the form of dust. Most of that dust is just a few microns in size, floats up high in the atmosphere and stays there for several years, and then finally settles down on the Earth. But as you increase the size, then the number of objects that are bigger gets smaller. That's a good thing for us. It means the ones that really threaten and can hit and cause a major disaster are fewer than the small ones that say threaten the space station.
um, maybe we'll just take the last question. And we have a question from Neeraj Ladia, who's an educator at Space. And he says, I've been an active participant in AIASC. Just wanted to know why there are less discoveries this year in AIASC. And
That's oh, I'm sorry. Go ahead.
no, yeah, I'll let you answer that.
All right. That's an excellent question, and it's a problem. What's happening is that we have several large sky surveys that have been in operation for the past 5 years, and basically what they've done is they're sweeping out all of the asteroid discoveries. Now that's one reason. So there are fewer objects for us to discover. The second thing is that in northern latitudes during the summer months from May to June, the location of the asteroids are far in the southern skies, along the band that we call the ecliptic, and it's so you're looking. It's more difficult to make observations. The observations aren't as accurate, and so what we're trying to do is find a new site in the southern hemisphere, because during those months when we run the All India campaigns, the ecliptic is well positioned in the southern hemisphere during those months, and it's the best time to look for asteroids in the northern hemisphere is during the winter. So that's a problem, and we're not sure exactly what we'll be doing next summer, because we hardly discovered anything in the last. I think we had only one or two discoveries compared to multiple discoveries in previous years. But that's not going to improve.
So I think that's most of the questions, and we have other people here who say things like, "Thanks for the informational talk, and thanks for taking your time for this hangout." So I wanted to share those views, because viewers are enjoying this hangout and your presentation.
Well, you're quite welcome.
CB, do you have any questions?
Yeah, not questions, but just wanted to share it with Patrick. One of the points which for the past few years I've been wondering upon is that how good is the participation from India as compared to the rest of the countries in terms of the asteroid search campaigns? Do you think it's quite on the
As a matter of fact,
yeah,
it's so good that it's some of the best in the world. We could offer all 500 schools just to India alone. That's what the interest is from India. I get requests from India schools and students every single week. But you have some of the finest observers and measurers in the world.
Oh, that's quite an achievement for us, and it's an achievement for the people who train the coordinators and the students over there, because we have a set of pattern in which we train them. So I think that pattern is going perfectly right.
In fact, in those areas where they do that, that's done also in Portugal, that's done in Germany, that's done even in Venezuela. We have a group there who organizes about 20 schools a year. Uruguay.
Okay.
We have several locations in China, several locations that do just like you do, and that's where we have very successful organized campaigns when you do that.
Okay. So that means in the coming years we'll ask for more and more schools, isn't it?
We've got to solve the summer problem, and but I'm trying to get you as many slots as I can. We have to solve the summer
Yeah.
problem before next summer.
Otherwise, we'll ask for a winter slot.
There's one more question that would be a good way to end this, and so I'll take that. It's by Bradley Smith. Thanks for the informative talk, Professor Miller. While asteroids can pose a risk to Earth, they can also provide benefits through asteroid mining. Should we view asteroids as a threat or an opportunity?
Well, most near-Earth asteroids aren't going to hit us, and so those are your opportunities. Some of them will hit us, and of course, those are the threats. But you're absolutely correct. You bring in a moderate-sized asteroid, maybe the size of maybe 10 or 20 meters across, or even bigger. It contains minerals and elements that are very, very valuable. There is a program organized by Chris Lewicki in Arizona that their goal is to go out and retrieve an asteroid, bring it back to near-Earth space, and then mine it for commercial purposes. There's also a discussion at NASA about sending a robotic spacecraft out to steer an asteroid in a near-Earth orbit, and then send manned missions to that asteroid to explore the asteroid and discover what riches it has. But you're right; it's an untapped reservoir of resources.
And this month we also have Rosetta and the Philae lander that's going to land on a comet.
Oh, that's absolutely fantastic! Absolutely fantastic. And
have we also learned more about the composition of asteroids from the ones that have hit us, and from the early solar system?
Well, those that land, we have a good idea that what they consist of, but those that land are not really a true representative sample out there. The Japanese sent out a spacecraft to an asteroid, landed on the surface, and picked up some material to bring it back. In 2016, NASA is sending out the OSIRIS-REx mission. It won't land on a near-Earth asteroid, but what it will do is it will edge up next to it and draw material off the surface, and probably bring back 20 kilograms of material directly off the surface of that asteroid and bring it back for study in the laboratory. Now, what would be interesting about that particular asteroid? It's a carbonaceous type asteroid. It dates back to the very beginning of the solar system. It's the original material out of which the planets formed. And so astronomers are very excited to get their hands on that pristine material, because it will tell them a lot about the formation of the planets and the development of the solar system over the years.
Thanks, Patrick. That was really a great talk. We learned a little bit thanks to you. So it was great for us to hear more about it and what programs are upcoming. And thanks for answering all the questions.
Well, it's my pleasure, and thank you for inviting me. I enjoyed it very much.
Thanks to all our viewers for joining this Hangout. And we'll also have this Hangout up as a video, and we'll have the link up on our space website. So everybody's free to visit the video again. And let's all join in thanking Professor Patrick Miller and Mr. C.B. Devgan for joining us today in this Hangout. Thank you.
Thank you.